excited to bring you a platform that helps users interact with Solana chain in a safer manner while also tackling the age-old problem of network congestion on Solana. So we're going to quickly go ahead and connect our wallet. We're using Privy to onboard our clients, so you can even use social media logins and quickly access our platform, hence reducing that accessibility gap. So firstly, when you come onto our platform, you're going to see this network status page. We're using a bunch of metrics such as the trading volume, the transaction count, the TPS, the average transaction fees, the total fees of transactions within a 10-second interval. And based on that, we're fetching out the failure rate and charting it for the user based on our prediction model. So this then clusters and buckets the failure rates into congestion level buckets. And right now, based on historical data, this is a pretty low congestion level. So our user can take a look at this dashboard and then from there gain insight on if it's a congested market currently or not, and help save themselves on the prioritization fees. So you can then go ahead and actually schedule a transaction with us, which is very exciting. So we're going to do that really quickly. First things first, you have to go ahead and import your wallet. So I put that my private key in here, and then after that I got my wallet details, and we also have the network status here as well. So you can simply send your Solana to another user, or you can actually schedule it based on the network failure rate. So currently it's a 36% failure rate. I'm feeling like 32% is a reasonable estimate for me, so I'm going to quickly go ahead and fill out the details for this. So there we go. I have scheduled a transaction with a user where if the current network failure rate dips down below 32%, it will execute. So let's just wait for that. And while that's running in the background, oh, okay, I think this should be getting into the pipeline now. You can also view your old transactions here, and you can see them get verified in real time on the Solana chain, as you can see. So yep, as we had predicted, this is getting processed in the background, and right any second about now, it should get posted onto the Solana chain. Let me just come back once that's done. Oh, wait, actually, I don't even need to come back. It's done already. And you can see this as well done on the Solana chain. And now we're going to cover our security features, and I'm going to pass my time to Cheyenne to cover that.
Hey guys, today I'll be talking about the security features of Solark. As we all know, Solana is notorious for being a platform where things like scams and meme coins happen, and we are trying to add more security features alongside verifiable builds. So, for example, we can go to the Solana verified directory. We can take any particular address in particular scenario. For example, let's take this one over here. Let's copy this particular address and insert it here. What we're doing here is we are connecting to the osec.io API and validating that the program ID exists and that this program is verified. The entire purpose of this is to go beyond verifiable and to make sure the code base is the same one as shown online, but also make sure that the code base is clear and functioning as expected. So as you can see, when we see the programs validated, we create a folder tree as well by getting its GitHub, which is the actual GitHub repo which it has posted. Then we also show it in different ways, including the folder tree, a D tree which shows the different files involved in this particular scenario and what dependencies and config it falls under, as well as the JSON file doing that. Moreover, we can press this button to scan code for vulnerabilities, and what it's doing is using using AI to effectively scan through the most important files in this particular repository and analyze any issues which may show up. So as you can see here, we are doing a code analysis issue, which figuring out any good or bad issues with this particular code analysis and figure out why it did not work. So, for example, in this particular scenario, we see that this has an issue with a transaction batch, and that the lack of checks on the authority of the transaction batch creator could lead to unauthorized access, or that transaction batch is created successfully with a zero flag, which is pretty good. All of these are particularly identified issues are listed here as well for more transparency, as well as generating a security report which gives you overall summary, highlights the different vulnerabilities, as well as recommends what actions need to be taken to resolve these, as well as providing some metadata on what what the repo link is, as well as the analyzed file. Thank you.